Hello pre-calculus and welcome to chapter 6. This in here is more trig, and we do a little bit of solving and some polar coordinates and all kinds of fun things. So you should have chapter 6 open, your calculator, and let's go. Alright, today we're going to solve oblique triangles, and those are just larger, they have different possibilities, and you can have one, two, or no triangles depending on what we're given. With the ambiguous case, we're going to use law of sines, and let's get going. Okay, now to use law of sines to find an oblique triangle, you have to contain a right triangle. Okay, it does not contain a right triangle. That's what this means. So they're not, you can't use just sine equals opposite over hypotenuse is what that's telling you, or cosine equals adjacent over hypotenuse. Those don't work. So we have to use law of sines and cosines in order to solve these. Now when you're going through, there's either 3 acute angles or 2 acute angles and 1 obtuse angle. All right, that's what we're looking at here. There's no such thing as 2 obtuse because that would be over 180. Remember, an obtuse is over 90 and acute is under 90. Now, your law of sines from geometry, remember, is the side over the sine of the angle, and all of those ratios are equal. You could have used it in the other direction too. You can put sine of A over A, sine of B over B, or sine of C over C. It does not matter because it is a ratio. We're going to use those to solve side angle angle and angle side angle triangles. All right, so let's look at our triangle here. We need to solve this. I want all sides and all angles. So when we look here, I have an angle side given. Well, that third angle is very easy to calculate, correct? So that's the first thing we do. So we're going to take 180 minus 6. Oh, I wrote that weird, didn't I? I would have taken 180 minus 64 minus 82, and that equals your B, which is 34 degrees. So now we, whoops, get rid of that. So now we write in 34 degrees here. We have all angles. Now we have to find all sides. So we look at what side was given and what angle we have. So this is the ratio we're going to use. The side of 14 over the sine of 82, because this was given to us. And now we can find A or B first. It does not matter. So then we do this A over the sine of 64. Now we're just going to multiply by sine of 64 on both sides to get A by itself. Type that into your calculator. Make sure you are in degree mode here and not radian. So double check your mode on your calculator before you do this. And you should get 12.7 approximately. We are rounding. So now we have this side. It is always a good idea to use the ratio you're given and not the new one you found in case you've made a mistake. So we're going to stay with 14 over the sine of 82. We're going to find side B this time, and we get 7.4. We have now solved our triangle. All right, try yours. Pause and do this. So you should have written in the 40 for the A, the 22.5 for the C. The first thing you should have calculated was your B, and you should have done that by 180 minus 40 minus 22.5. I did my calculations right. That's 117.5. So now we have all 3 angles. All right, we are given this side. Since that's the side we're given, that is the side we will use, you should have used for your ratio. So you would have done 12 over the sine of 117.5. Doesn't matter which one you find first. Let's say you did A over the sine of 40. Multiply by sine of 40 on each side. And you should have gotten A equals 8.7, approximately. We are rounding. All right, which makes sense. He should be less than 12 because his angle's smaller. So C should be even smaller. Again, we're going to use the same one we're given. So we start with 12 over the sine of 117.5. Should it equal C over the sine of 22.5 multiplied by sine of 22. And you should have gotten 5.2. I suppose I could write that in there for you. All right, and we have now solved your triangle. I hope you did a good job. Okay, down here. This is the law of science to solve triangles in an ambiguous case. That means I can have one, two, or no triangles. The first thing we have to do is calculate the height of the triangle. All right, to see what we have. Now this height, if you look here, whoops, when you type that in, we have a 90-degree angle. Well, to calculate that height, it's literally right here. So this height is equal to, so the sine of A, if we look at this, because it's a 90, is equal to the height over B. Well, if I need to calculate the height, I just multiply by B. So it's B sine A equals H. That's where this formula comes from. And that's true on all triangles. Now, we have to compare the side, the A side, to this height. So if it's larger than B, so now if I have A, right, and A is greater than the height, and it's greater than B, it's both. If it's bigger than everybody, there's one triangle. All right, now we're going to compare the A to the H. So if A is equal to the height, well, that's a perfect 90. There's still one triangle. All right, if A is less than the height, yeah, let's write it this way. So if A is less than the height, you can't get a triangle, so it just hangs there. It can go here to here, like if you rotate it, but there's no way it will ever touch that other side. So then there's no triangles. This one's probably my favorite. If A is greater than the height, but it's less than B. So it's less than this side, but it's bigger than this side. You get two triangles. You get this smaller one right here, and then you also get the larger one right here. When we're calculating this, the thing that I think is very interesting is this triangle that's calculated by the A is an isosceles triangle. And we can use that to help us solve both of those triangles. All right, so now let's look at a no triangle one. So we have, here's our triangle, you draw it in, this side goes on forever, we do not know how long it is. We put in 50 degrees right here. We're given B is 20, because this is A. Now we have to compare A to everything else. So step one is you have to calculate the height. So I have to figure out how high this triangle is. Well, that's done by B sine A, right? So we take 20 times the sine of 50, make sure you're in degree mode, and we get 15.3. That's how high my triangle is. Well, the side length, A, right here is only 10. It is too short to hit the bottom ray. Since it cannot hit, we have no triangles. All right, your turn. Pause and try it. So you had an angle of 75. You have B is 71, because this is A. You calculated your height, so that's equal to B sine A. And you should have gotten 68.6. So this height right here, not part of your, not the side of a triangle, is 68.6. Well, now I look at A, and A is only 51, so it goes to like here. Cannot reach the bottom ray? No triangle. All right, these are some of my favorite. Okay, let's check here. What do we got going on? I love pictures. It helps me understand. So we have 35 degrees for A. We have B is 16. We have to calculate that height. Nothing changes. So my height, we do 16 sine this, is 9.18. Well, this time, A is 12. So when I draw it in, it can go here and hit because it's longer than 9.18. And then when I swing around, it can also go here. So now I've got an isosceles triangle, which means both of these angles are the same, if you remember. So now I've got to figure out how to do this. Now, there's a couple ways. Your book does it. 12 sine of 35 equals 16 sine of b, which gives you this angle over here. All right, which is fine. Uses law of sines. Pretty easy. The other way to do it, let me show you just because I think it's interesting. When we drop our height down, this is a 90. Well, if that's a 90, I can use law of sines. So the sine of this angle, or the sine of b, is equal to, it's just opposite over hypotenuse. 9.18 over 12. Use your inverse sine of your opposite over your hypotenuse, and you get your answer. Okay, so when you do the sine, you're going to get the exact same value you do as if you do it the other way, which is also going to give you, I got to calculate it out here, roughly 50 degrees. The part that I like about this is it makes finding the other part a little bit easier. Because to me, I can understand this. So this guy right here is 50. And then this guy right here is 50. This line here, so let's draw this out. So this is the part of my triangle. That's 180, so this angle has to be 130. So this I can understand and I can visualize. I don't care which way you do it. They both work equally well. All right, so we got our 50 and our 130. We have our two triangles. So this one here, oh, it's above now and you can't see it. Let's redraw him in. So this guy is the big one. So we've got 35 here, 50 here. We have 16 here, and, whoops, that's terrible. We can calculate C by taking 180 and minus 35 minus 50, and that's 95. And now it's just law of sines. So we take opposite of 35 is 12, because that was A. So 12 over 35, we got 16 over 50. We need to find the 95 over C. So we do 95 over C, use our law of sines, calculate that out, and C is 20.8. Okay, so that's the one with all three acute angles. Now let's do our other triangle, the one where we had the 130 over here. So we have 130 and 35. Subtract those out and we get 15. We still have our same side lengths. So this is 16 and this is 12. All right, I need to calculate this, which is the same thing. So we do 12 over the sine of 35, C over the sine of 15, and this time this answer is 5.4, our two triangles. All right, I kind of enjoy those. I hope you like them too. All right, pause and give yourself a shot. So let's draw this guy in. This is 40, B is 62, height is 62, whoops, 62, sine of 40, which equals 40. That was weird, huh? So this height right here is also 40. Okay, A is 54, so he's going to show up on both spots. So he's going to go here at 54 and down here at 54, creating my isosceles. I think I'll do it the other way, just so for those of you who like to do it in that direction. So now I need to calculate the sine of A. So we're going to go 54 over the sine of 40 equals 62 over the sine of A. We're finding this angle right here. Nope, that's actually B. Let's get rid of that. Let's put a B in here. So we're finding this guy. Okay, do your law of sines. So we've got the sine of B equals 62 times the sine of 40 divided by 54. So the sine of B, and I don't clear my calculator here. I let this in so I don't round until the very end. Now you do your inverse sine of your answer, so don't round here, and you should get roughly 47.56. All right, they always want you to round the degree to the fullest degree, so that is approximately 48 degrees when we round that. So this guy right here is 48. So right now we're working on the big triangle. So we're working on this guy. We've got 40, we've got 48, we have 62, we have 54. This angle is 180 minus 40 minus 48, which is equal to 92. So this guy right here is 92. We need to find this side right here. So it doesn't really matter which one you use. I'm going to use the 40. So we're going to do 54 sine of 40 equals C over the sine of 92. Do your math, and you should have gotten C to equal 11.7. No, I'm sorry, 51.5. I'm on the big triangle. So this guy right here is 51.5. So next you got to do the small triangle. So that's the one that went in. So this is still 40. Our angle here, we're going to take 180, minus the 48 to get this angle right here. And that's going to equal 132. So we just found this guy. That's 132. Okay, to find this guy, we're going to take 180 minus 40 minus 132, and we're going to get 8. So this guy right here is 8. We know this side is still 62. We know this side is 54. We're calculating this side right here, and we'll use our law of sines again. So we're going to go 54 over the sine of 40, because that was given, no rounding necessary, equals, technically C over the sine of 8. Do your math, and you should have gotten C equals 11.7. Right, quite fun, huh? I like those. All right, one triangle. So life is getting shorter, right? So this time A is bigger than everybody. So let's draw in our triangle so we know what we're working with again. So this is 43, B is 62. Our height, 62 sine of 43, is 42.3. Well, this time B is bigger than 62 and 42.3, so it is way out here. If I swing around, he's over here, which is off of my ray, so there's only one triangle. So now when we look at this, we just do law of sines. So I got 81 over the sine of 43, 62, let's find this angle, sine of B, do our math, we do our inverse sine, and we get 31 degrees. Okay, next, subtract 180 minus 31 minus 43, and we've got 106 for the top one. Now we can find side C by law of sines again. Let's do 81 over 43, C sine of 6, do our math, and we get 114.2, which is side C. And we're done. Those are quite interesting. Not as much work as the double ones. All right, pause and try yours. 57, 26, H is equal to 26 times the sine of 57, which is equal to 21.8. So this height here is 21.8. A is now larger than both of them, so he's way out here at 33. So we have one triangle. So now let's do 33 over the sine of 57 equals 26 over the sine of A, sine of B. Calculate this guy out. So we're trying to find the sine of B. So we know the sine of B is equal to 26 times the sine of 57 divided by 33, which equals 0.66077. Remember, don't clear. Do your inverse sine of that answer. And you should get roughly 41.35, which rounds to 41 degrees. Okay, subtract out. So let's take 180 minus 57 minus 41, and that is equal to 82, if I did my math right. So this here is 82 degrees. We got this side left to find. Law of sines. So let's do 33 over the sine of 57 equals C over the sine of 82. Do your math. Good morning. Sorry about that. Okay, now when you solve for C, you should have gotten C equals 38.96, or when you round that, literally 39. All right, I hope you had fun with that one. Okay, let's do a little bit of area. Okay, we have a couple formulas for area. One of them is just area of an oblique triangle. And this one here is 1/2 BC sine A. So what it is side 1, side 2, included angle is what this means. All right, so when you're doing this, if I have BC, 1/2 BC sine A, that's how you actually find the height. But when you have the B and the C, the included angle is A, so it has to be sine of A. If you have the A, the B, and the A, the included angle is C, so it has to be sine of C. If you have the A and the C, then the included angle is B, so it has to be sine of B. So it's 1/2 side, included, sine of included angle is the easier way to remember that. So when we go through here, I have side, included angle. So it's 1/2, 8 times 12 times the sine of 35, 34 meters squared. Okay, your turn. So area equals 1/2. We have CB, included angle, so we can do this. 24, 10, sine is 62. Make sure you're in degree mode. Literally type that in your calculator, and you get 10.7 equals side A. Or, sorry, not side A, equals area. All right, let's go. Oh, should have said meters squared. I'm sorry, I forgot my label. I would have yelled at you for that. Okay, law of sines. Let's see if we can figure this out. Grab a partner if you have one. All right, so this is bearings. So bearings means two fire stations are 13 miles apart, so the 13 comes here. If I tell you A is north and then 35 degrees east, I go north and then 35 degrees. To find this angle, you have to subtract that from 90. So you're literally doing 90 minus 35, which equals 55. So this angle here in my triangle is 55 degrees. Here, we went north, 49 degrees west. So this is 49. Again, 90 minus 49 equals 41. So this guy is 41. I asked, how far to the nearest 1/10 of a mile is the fire station from B? So I want to know where this fire is from B. So I'm asking for this side. Since I want to know that side, or side A, now we're using law of sines. So we're going to do, I got to calculate C. I'm sorry, I forgot. So we take 180 minus 55 minus 41 to get our C, which is 84. Okay, now it's just simple law of sines. So we'll do 13 over the sine of 84 equals A over the sine of 55. Do your math. A equals 10.7. So this is 10.7 miles from B. That's how far away the fire is. All right, good luck on your homework. Make sure you post discussion questions. All right, see you then.